Good morning. We are going to revise 2017 paper 1 GCE, the question on electricity. The question goes as follows. Figure BB1 shows 3 resistors connected to a 12-volt battery. Calculate part A, the effective resistance between X and Y. The effective resistance between X and Y. So the effective resistance between X and Y, it is same as asking us to find the equivalent resistor or the combination of the two resistors. So now, we are going to label the resistors that we have in the circuit. So this one will be our R1, then this one will be R2, then this one will be R3. So we have resistor 1, resistor 2, and resistor 3. So the one they want us to find the effective resistor or the combination of resistor, it's R2 and R3. So now they are connected in a parallel. So for the parallel connection, we have to apply this formula. Since we have two resistors that are connected in parallel, so our formula will be equivalent resistor equal to resistor 2 times resistor 3 over resistor 3 plus resistor 2. So it's resistor 2 times resistor 3 over resistor 3 plus resistor 2. They are in parallel. So equivalent resistor will be equal to resistor 2 we have 12 times resistor 3 we have 6 over 6 plus 12. So our equivalent resistor is going to be 12 times 6, which is equal to 72 over 18. So if we divide 18 into 72, we are getting 4. We are getting 4 as our equivalent resistor. So take note, this formula is only applied only on two resistors that are connected in parallel. When you have 3 resistors, you have to apply a different formula. Or better, you apply this one, which is 1 over equivalent resistor equal to 1 over R1 plus 1 over R2 plus 1 over Rn. So that's the formula you should apply in parallel connection just for the parallel circuit, where N represents the number of resistors connected in the circuit. We go to part B. The current flowing in the battery. The current throwing in the battery. The current flowing in the battery. So they want us to calculate current which is coming from the battery there. So what we have calculated here, the equivalent resistor we have calculated, we can label it here. So this is our 4 ohm resistor we have calculated. after finding the equivalent resistor for R1, R2 and R3. So this is what we are getting. So now, to find the current that is coming from the battery, we need to know the total resistor between resistor 1 and the one we have calculated, which is going to be resistor 4. So now, to find the equivalent resistor of the two resistors, R1 and R4, the two are connected in a series. This is a series connection. You can see, this is a series connection. So it is just the matter of adding R1 to R4. So now R total is what we are calculating now. So R total will be equal to R1 plus R4. So R total will be equal to R1, it's 2 ohm resistor, plus R4, it's 4 ohm resistor. So 2 plus 4, it's 6. So if we add all the resistors that are given in the circuit, we are having 6 ohm resistor as our final. So now we can calculate current by applying Ohm's law. So Ohm's law states that voltage is direct proportion to the product of current and the resistance. So we are looking for current total. So I will say current total equal to voltage total over R total. So current total equal to voltage total. We have 12 from the circuit there. It's 12. So we are going to apply 12 here over where there is the RT, we apply 6. So 6 into 12, it's 2. So the current total is going to be 2. We go to question C. The current flowing through 6 ohm resistor. The current flowing through 6 ohm resistor. They want us to calculate the current that is passing through resistor 3, which is 6 ohm resistor. So now to calculate this current, we need to know the voltage drop of 4 ohm resistor. We need to know the voltage drop of this 4 ohm resistor. So VR4. We need to know the voltage drop through resistor 4. What we are calculating is current passing through resistor 3. And we have current total, which is equal to 2 amps. So R1 and the R4, they are connected in series. And remember, in series, current remains the same. So the current that is passing through resistor 1 will be equal to current that will pass through resistor 4. it will be equal to current that is coming from the battery there. So in short, we are saying IT is equal to IR1, which is equal to IR, which is equal to IR4. So now I total, we have 2 amps. So which means IR4 will be equal to 2 amps as well. Which means the current that is passing through resistor 4, which is 4 ohm, it's 2 amps. So now we can calculate the voltage drop. So voltage drop through resistor 4 equal to IR4 times R4 itself. So voltage drop passing through resistor 4 equal to IR4, we have 2 times R4, we have 4. So the voltage drop will be equal to 8 volts. 8 volts. Which means the 2 resistors were sharing this voltage. R2 and R3, they were sharing 8 volts. And remember, when the resistors are connected in parallel, voltage does not change. So the voltage drop, which is passing through resistor 2, which is 12 ohm, will be equal to voltage drop passing through resistor 3, which is 6 ohm. So now to find the current that is coming to resistor 3, it will be very easy because we have now everything that can help us. Therefore, current passing through resistor 3 will be equal to voltage drop passing through resistor 3 over resistor 3. So IR3 will be equal to voltage drop through resistor 3, it's 8 over resistor 3, it's 6. So if we divide the two, we are having, so 6 into 8, it's 1.33 amps. So that's the current that is passing through resistor 3, which is 6 ohm. Thank you for watching. This is Mr. Mrenga E. Don't forget to subscribe to my YouTube channel for more videos in physics and mathematics.